now we got a mic and everybody can hear. Yay. Okay. Oh, we're back live here for Thursday. Got my cough drops. Can't get rid of this cough, which sucks. I've had so many cough drops. I want to just like shoot myself. Anyway, we were hacking on our function that's supposed to be working on a stream of bytes.
Yep.
Trying to figure out length bytes, where the data's coming in haphazardly, which is going to happen with TCP. I think it was a good idea to switch to the sort of little hack program that we had started. And Kevin was just using Cursor a little bit to remember how some of the code worked. And I forgot that we added this new function, which was there to make sure that is length is true for some reason. Now, for everybody that was following along last week or Tuesday, excuse me, we were just hacking on this function here. But where was I hacking? I wasn't hacking here. I switched.
You were.
Didn't I? I switched to Bill. Yeah.
Oh.
I switched to Bill. That's why it was working, because we hadn't gotten to the hack yet.
Gotcha. Okay.
Right? Like, we weren't working in here just yet. We were now working in whatever. We were working in Bill, so we could sort of hack it. Then we would put it back in our hack program, make sure that's working. Then you can put it back in. So we got it. We did a second hack, right?
Got it. Okay.
And I know that this code is ugly as sin, but I don't care right now because I just want to get it to work. And then we're going to look at what's working. We're going to optimize it. And then maybe we'll ask AMP to get its thoughts. Dude, I don't know what's happened, but lately I've had to turn off the tab completion. It's just been, even with AMP, it's been so much in my way.
I wonder if you can adjust like the sensitivity of it.
I'm starting to learn something. When I'm in hack mode, I have to turn it off.
Yeah.
When I'm in engineering mode, I turn it on. This is kind of where I'm at this point. It gets in my way when I'm trying to hack because I know I'm writing really bad things because I'm throwing rocks at stuff and it's trying to help me and I'm like, stop.
Yeah, it's trying to clean it up and give you like...
When I'm in engineering mode, I kind of want it there looking over my back, right? Yeah. So I got it off right now. Now, I think when we left on Tuesday, we didn't have this working just yet, right? We want to be able to see this whole sort of stream of consciousness. In fact, we should put spaces here. So when I print the whole thing out, we get it, right?
Okay.
So let me do that too on this. And maybe one of the other things, because I remember when we were looking at this, was sort of, this was sort of getting in my way a little bit, right? Like just do a print. And I don't even want the print line really. It should just be a basic print if we're going to sort of do this right. Right? So I should get back this whole thing in one big sort of sentence, right?
Okay.
In fact, one of the things we could do, even just to get a visual here, is the idea would be this, okay? So that would be the original. And then we should see it get produced again if we're doing things. And I'm trying to haphazardly, randomly sort of decide how many bytes in this stream that we're going to be managing, right? So, and even this we could sort of clean up into a single. I did that just because it was easier to sort of look at in terms of the data, right? But the stream could easily be strings dot join data, and I mean the separator could have been a space, but I could just do that, right? Like join all that together, then it's a matter of, now I can do, say, a print line for the stream, right? I don't need to do this. Here's a stream. And then sort of work with the stream, right? I'm going to put an extra print line here. So think of this as the actual stream of data. We'll display the original stream. Then instead of ranging over the slice here, what we can do, we could do there's not a split. What is it called? There's one where I can get words. We'll split on words. And it's not words. It's, I can never, the API isn't obvious here. I'm going to look it up online. There is a way of splitting, and I've used to try to do some basic tokenizing, right? So golang split string in, by words, right? There's support for this already. Just can never. Oh, strings.fields. Let me see. String.fields. Yeah. So this is going to give me the words, basically. Oh, but I'm back in a slice of words. But it might give me... Actually, it shouldn't matter. Let's not do this. I have a slice of some stream, right?
Okay.
And I know what the length of this is. This is a matter of us sort of just sending in... oh, but we had to add... Okay, I forgot.
We have to add the 2 bytes.
Add to the bytes before we call Kevin, right? And we have to... so I'm just trying to think, if I take this, create one stream, pull so many words out at a time, but I'll use the spacing. So we pull so many bytes out at a time and sort of just send those bytes, right? It would be kind of, I think, more interesting, I think. So almost like, what if I did this again, right? But this time, let's say we use up to 20 bytes at a time, right?
Okay.
So we get some 20 bytes. And then what we can say is we're going to send, related to our stream, that V, whatever that V is, right? That's going to give us a string of V bytes, essentially.
Okay.
Okay. Then what we have to do is essentially, let me steal this code here, where I get the length of that send, and I put it into the lbuff. Now I've got an lbuff, right? Now I know how many bytes. I put it into the 2-byte array, and I can essentially, I don't remember what we did here, but I want to call Kevin with a buffer, right?
Yeah.
Let me see. I'll keep all this together. So what do I want to do? I need the lbuff plus sort of these bytes all together in one buffer, right? Just because I want to send it all together. So I could just do, again, inefficiently, but that's fine. I just want
that code. Do you append?
Yeah. So I want this code for sure. And then I've got basically what we're going to send, right? Will be another append. What we're going to send. Now, this is a string, all right? But that's not a big deal because the string is really just bytes. Should be able to do that. And yeah, we're not using it, right? And then the idea is to call Kevin. Let's see here. And I think we return the buff, but I won't need it. Let's see what happens here. Let's think about this code. Now, the first time I use send is kind of here anyway, isn't it?
Mm-hmm.
So there's a couple things now that we're going to have to do. Well, let's say we call it send. But once I do that, I have to take that out of the buffer. The stream has to move, right? So this is just saying this is what we're sending. But one thing I'm going to have to do now is say send is going to equal actually v, right? Just to take those bytes out of the buffer. And the other thing I'm going to have to do is once the length of send, right? If the length of send equals 0, then I got to break because we're done, right? That's the whole point. Not send, but stream. Sorry.
Okay.
Once there's no more bytes in stream, we're going to do that. Now it looks like, right. I can lift that into the loop, couldn't I?
Okay.
And once there's no more bytes in stream. Now, this number might be too large, right? So if v is greater than the length of the stream, then v should equal the length of the stream, right? Again, kind of inefficient to keep calling length, but that's okay. Now, here's another
using min.
Nice. So we randomly pick a number, compare it to the length. We choose the one that's minimum.
Okay.
Now, is minimum going to be right? Because, oh yeah, because if this is 20 and this is 10 and that's what we have left, then we'll do 10. So that's kind of cool, right? Then we know what we want to send to the other place. So we get the length of those bytes and we convert that into the little endian 2-byte number.
Mm-hmm.
We then create a buffer. We put the length, we put the bytes in there. Then we call Kevin. We're expecting at this point for Kevin to process all of those bytes.
Okay.
Yeah, the whole point, Kevin's always going to process all of the bytes that we've given it. It has its own buffer that it's maintaining, but from this call, it's processed these bytes. Then we take those bytes out of our stream and we come back in the top, and eventually that shouldn't blow up. That should be 0, right?
Mm-hmm.
So this is going to be kind of a more accurate way of doing it. This is going to be like our read call, just saying these are the bytes that we got.
And then Kevin.
Now the problem though is, this isn't going to work. Only because, okay, the way I've written this now.
Mm-hmm.
Oh no, that's fine. We have different lengths, which is fine. We'll have consistent lengths on the other side.
Yeah. So this is randomly selecting
So
many bytes from that sort of
telling you what to read. And that's fine, right? Like this is what we need. Even though it's probably going to be more consistent in the final where you'll see 40, 40, 40, 49, 60, right? And then eventually it gets smaller. This will be a little bit more chaotic.
Yeah.
We can handle this. We can handle sort of anything, right?
Got it. Okay.
Now, when we call buffer, the whole point is that we're going to be processing all of the bytes. So I don't think we need that, right?
So we're not returning any bytes.
No, because we're going to process everything by the time we're done. So we're just doing this. That's fine. And again, even this is kind of interesting, right? Because the ideally, if length, right, then we're sort of done with the loop, aren't we?
Mm-hmm.
So I'm shocked that the editor didn't, or the Go tooling didn't tell us to do the same sort of thing we did here, right?
And it was done twice also. On 61, we're doing it.
We might need to do that there though. So let's see what happens here. So the first thing we said is if we're expecting length, we decided to write a little flag. Maybe we can get rid of that. But if we're expecting, why are we having a go mod problem? Delaney too, but we're gonna have to do a go mod tidy, I think. I don't know why. Mod tidy. I don't like that being red. All right. So that's better. Why are you red, dude? Inconsistent vendoring detected. Please run go mod vendor, which go mod tidy was supposed to do. Go. Oh, I have the make command, right?
Yeah.
And my brain just went into the actual running of the command.
Okay.
All right, it's fine. So if we're expecting a length, and in the beginning we are expecting a length to be true, that's why we hard coded it true there. Then we take the first 2 bytes, we set that to false. I'm actually going to get rid of some debugging right now. Now, after we get the 2 bytes, it's quite possible that we don't have any more data.
Yeah, that was the only thing there.
Right? So we just double check.
Yep.
Now, the problem here, though, is there's no more data, but we're going to lose this information. And then when the next bytes come in, what happened? Right? We lost the length. So there's a bug right there for sure, right?
When you say we lost the length, where? On...
Oh, no, we wrote the chuck length here. Okay, that's fine. We saved it here, right? So this is the current. We're inside a chunk now, and this is the current length. So we save that.
Okay.
Now we might return. Now when the bytes come in, this is false. So we have a current chunk length. Like, we'll have to do this better. But I thought for a second we lost the state.
Okay. Okay.
Now, this says that, if we remember this, this says that we've got less bytes than what we're expecting.
Yeah.
Okay. So if we have less bytes than what we're expecting, we can print those bytes, remove them, write that we've done that. This will probably then get to 0 and we'll be done, right?
Yeah.
This says we have the exact same bytes. So, we did all that. But in this case, I said written 0. I reset 0 here. And then we had more than enough bytes, so I reset 0 because I know that we got everything that we needed. Now, I just want to go back to this streaming thing because what I don't like about what I did here is that on every call, I'm sending length and bytes, and that's not realistic. What we want to do is do a length, n number of sends of those bytes, and then a length and an n number of sends. That's going to be more realistic than sort of what I've done here. So what we might need to do is we can send the length, but we probably shouldn't send the full number of bytes per se. So only because we're not going to be able to test this idea that some packet came in and it had a length and some bytes, and then we had a couple packets of just bytes, and then we had a packet of some bytes with a length. Like, this is what makes this sort of hard to sort of simulate, right?
Yeah.
This isn't good enough because I said, let's randomly pick 20 up to 20 bytes, right? Keep that in the buffer. Let's identify the length. Let's create a buffer with that length. But then let's send the 20 bytes. That's not good, right? I want to call Kevin almost. I almost want to do this. Let's say that I don't know the best way to simulate this, but I mean, one really bad way to do this would be to do this. I mean, you do this and it's game over. For I range, what are we going to do? Send? Length send. This gets really ugly, but it gets interesting to me. What are we going to do? We're going to send. Oh, what would happen too if we did that? Imagine this scenario, bro.
Position.
Now, this isn't expecting 1 byte. It's expecting
Slice of byte.
But imagine this crazy scenario.
Makes sense. 2 bytes.
I'm sending a stream of 1 byte at a time.
Yeah.
Now, it would make this code blow up because this code's assuming that the length is always going to be there, right?
Mm-hmm.
Like the 2 bytes are going to be there.
Yeah.
And in this particular case, it might not be. See how
it might not be
complicated this is.
because it could be 1 or
yeah. So, right, solve this problem. And we solved all of it. So this just got even more complex, right? Because we're going to send in 1 byte at a time, and it's going to have to sort of put this back together. So here's a buff of bytes that just came in, 1 to many.
Yeah.
We know that we're waiting on length, and we know that length requires sort of 2 bytes.
Yep.
So now what this makes me think is maybe we need something here like, I'm not going to call this buffer, but I'll just call this buffer for now. Okay.
Okay.
Like these are fields that we would have in our thing. So maybe what we do right out of the box. Just like that. And we could probably use a copy. We did this more efficiently too. But let's just do this for now.
Okay.
Okay. So we take these we put it into the buffer.
Yep.
Okay. Now we're going to process the buffer until it's 0.
Yep.
Now, if we're looking for a length, now what we can do is say if the length of the buffer
is greater than 2 or something, or
is greater than 1, right?
Or greater than 1. Yeah.
Then we could do all of this. But if it's not, let's say if the length of the buffer is less than or equal to 1, then
break out.
We break, right? Let's put a note here. So we don't have the full 2 bytes of length information, right? We know that we're waiting for length. We don't have the 2 bytes.
Yeah.
So in this case now we do have the 2 bytes, right? So
beyond that, yep.
So we have the 2 bytes for the length, but we have to be smart here. Now we're going to be processing buffer. Then
now everything turns.
Pull that out.
Yep.
And then we say, if we have no more bytes to process.
Yeah, that means we just got like the 2.
Return to get more, right?
That means we just got the prefix.
Which is going to happen to us now in our new crazy scenario, right?
Yeah.
And at this point now there's bytes in the buffer. Now the length of buffer in this case is always going to be 1, isn't it? Like in my new scenario, right? It's always going to be 1. So if 1 is less than the chunk length, which is what we're showing here, plus what's been written. So if 1 is less than 0, because right now, our chunk length could be our chunk length is going to be whatever I'm sending here. So it's some still random number of bytes, right? So let's say that the answer was 10.
Okay.
So we wrote 10 to these 2 bytes. We added the 2 bytes for 10.
Mm-hmm.
I then added all 10 bytes to this.
Okay.
And then I call this 1 byte at a time. So first byte, second byte, now we have the length. The third byte, we'll say, well, we'll say the buffer has 1, chunk length 10, nothing's written, 1 is less than 10. We're going to be in here. We're going to print that byte. We're going to remove it out of the buffer. We're going to write that we've written that. We're going to come back here. Buffer's going to be wrong thing.
Yeah. Then you,
Buffer's going to be what? 0.
0. Yep. Buffer. There's, I think, on 79.
Okay. Yeah. So,
okay.
So we're going to live in this space, I think, the whole time.
Yeah.
But let's just see what happens with this weird scenario. So we're handling this, and then this is, we have less bytes in the buffer than we need, right? To complete are expecting. That's what this scenario is. All right. And this scenario is, which eventually we get to, we have the exact number of bytes in the buffer. The buffer we need, right?
Yeah.
And this is, and we have to still do this case, right? We have more bytes. And we need to handle this case. We're not doing it than we expect for this next sort of thing. Okay. I'm just sort of curious what happens now when we run this, though. The funny thing is I'm struggling the most coming up with a test. Like,
yeah, like how do you?
So the bad news is that this did not work. At any level. We didn't get anything printed out. So let's double check something now. For stream,
we're not doing a print.
Length of stream. Oh, sorry. Well, stream is greater than 0. Let's do that. Okay, fine. Let's put some prints here now, right?
Yeah.
Sending bytes, and we're going to be sending L bytes, right?
L.
And then we'll be calling Kevin 1 byte at a time. Okay, so sending 2, sending 9, sending 18, sending. So we did all that. Okay, so we know that we're calling Kevin.
There's no.
Let's just do this real quick. Called Kevin.
Okay.
Length buff. All right. Boom. Ooh.
1, 1, 1, 1.
Well, we expected that.
Yeah. That's
we
what
expected that.
So we
okay. And then we expect if I'm okay. So we did this. Oh, if length of the buffer while it's greater than
0. Yeah.
That was my bug.
There we go.
Yes and no, right? We see I'm happy. I got some carriage return, and then we got every morning.
We missed the exercises.
So some weird stuff is happening there, right? Plus,
it's like in a random order.
I don't know why we've got carriage returns coming in. So we're not processing things obviously appropriately, right? I would say that we got the first set of bytes.
I'm happy. Then there's Cadgeturn. Then
So let's play this game out now, right? So my guess is that if we were just gonna do this, we got a length at this point, correct?
Yep.
And that's the chunk length. So if we just run it this way for a minute, we got 15, and then we never get another chunk length again. Okay. So there's one bug.
Yeah.
We're never back into that we should have a length. Now,
yeah, we never get back into that.
We never get back into that. And so we've got some logic here that is not resetting the fact that we've got the full sort of chunk, right? Okay, so that's good to know. So we expect it to be in here. We expect that, but we do expect eventually that we're also here, don't we? We expect it to be in these two scenarios.
Yeah.
Okay. So let's just do the following then. Print line. And we can say that this is the less, right? And we can display that. And display that. Maybe even do it like this, right? D less than %D. Right? That's what we expected, right?
Yep.
And this is supposed to be the same.
Yep. It's equal.
So now I'm just curious what it looks like for that first beginning.
Always 18.
So less than 18.
And we're getting like the...
Right. We got happy. We got the space. And then we're here.
She... X... Which...
But that's true, right? Because we were expecting 18. I don't think this is 18 bytes. Hold on. What does my editor say? It should tell me. Selected 10.
10.
Okay. So,
okay.
Right? That was 10, 11, 12, 13, 14, 15, 16, 17, sort of 18.
And there's a blank spot when there shouldn't be, because that's in the middle of the word exercise.
So you see, we see exercise. We got the E.
So and
then it's almost as if we're not. I wouldn't be surprised if this. When did it end? Here? I wouldn't be surprised.
If that's 18.
18. Okay.
Yeah.
Okay, perfect. So we get this, and
that's where we end.
We stay in less, right? Almost the whole time. We never see the same, do we?
No.
Okay. So let's play that out.
The chunk length and written seems like it's not getting updated though, right? Like, shouldn't that change?
Yeah, we're gonna have to print out this now, but we know where we're at, right? We're in a much better place than we were here. What's funny is, yeah, then we printed that I, and then it's fine. Okay. So then there's a couple things. We definitely took the data out of the buffer, or we wouldn't be seeing this.
Yeah.
So the buffer is, and oh, I'm an idiot. You gotta write the bytes before
it's empty. That was the
before you process that. Okay.
Yeah, because it wasn't updating the chunk length. It was just staying.
Now, this time
The difference.
We had 6.
And there's an equal.
Let's run it without the extra debugging now. Right? Okay, so our bug was that we were doing the add in the wrong place.
It was adding an empty string or an empty slice.
It was always going to be 0.
Yeah.
And so we weren't processing it. But we know something now. We know that sort of this is working because we're randomly we're not hitting this case yet. But we know right now that if we pass 1 byte in at a time, okay, we can print that. We deal with the length of written bytes. We then sort of do that. And then we know in this case that we've got everything. We know the next 2 bytes has to be a length marker. What we haven't done yet is this one here, okay?
Where we have more bytes than we expect.
We have more bytes, so we're going to keep those bytes. However, right, so we're getting the diff, we're printing it. Just for consistency, we do that first. Then we process the buffer, and then we do like so. We've got to get this working now, okay? So how do we do that? We have to send in more bytes than the length, which also includes sort of the next length, doesn't it? And what that would mean to me is we change this stream a little bit.
Okay.
Instead of doing it this way, let's do it this way. Let me just do this for a second. Let me range over the data. Okay. And let me calculate for each piece of data what the length is going to be. Okay. So I know that this is the length of the data, right?
Okay.
This is my length D. Okay. Now what I want to do is let's use a string builder instead. So now I want to say, actually, we can use a bytes builder. Let's use a bytes builder. I believe there's a byte.
Byte.
No, it won't be bytes. It's going to be a bytes package. How is there not a bytes package?
It won't be a singular like byte builder?
No, because that's a type.
Oh, okay.
Unless I've done something here. Let me see something. Now my brain is just curious. Bytes package. I know there is a bytes package, just not bringing it in. All right. I'm not completely losing my mind. All right. Oh, there's no builder type. What is it called? A buffer. Sorry. Sorry.
Bytes buffer. Okay.
So now I can say stream.write the length D to this buffer. Okay.
Write the length D to the buffer. Okay.
And then I'm going to take stream.write again, and I can write the string, which is D, to the buffer. So I'm going to do length and then string. And I'm going to build the stream this way. Okay. And then stream dot, let's say if I wanted to print everything. Now we'll see some weird stuff because we're going to see lengths in there.
Okay.
So now the stream is more accurate. It's 2 byte length and a bunch of data, and 2 byte length and a bunch of data, and 2 byte length of all different sort of sizes.
Oh, okay.
Okay. Now, and what if I just call this a stream buffer? Now I can say stream equals streambuff dot bytes. Okay. And now I can start sending the bytes in one at a time, which still isn't really what I want to do just yet. So let's figure out now. Well, maybe this is better. I'm going to randomly now choose some bytes out of the stream. I don't know what I'm going to end up taking, right?
Okay.
I don't need this. Oh, look at this. This is even better, dude. So now that the stream has both length and data in it properly, it won't be a one-to-one match because we'll see some funny things in here, but it's okay. Yeah, instead of printing this, I should do this. Print D, right? Instead of this. So this is cool now because now I'm just going to randomly pick up to 20 bytes at a time and send that. Now, however,
which could have links mixed
so
in there.
if
That's the idea. Okay.
Okay. Stream
Yeah.
is less than V, then V has to equal length of stream, right? That way, oh, it's going to tell me to use the min function again.
Yeah.
I always forget about it, and there it is. Cool. This is now 10 times more accurate because this is how it could really be coming in over the wire.
Yeah, you'll get length, random bytes, random length, random bytes. Like...
And, you know, when I was coding this stuff in C# and C++, you always got some random sort of, even though you were sending it, say, in a uniform way, it wasn't coming back in. Now, Go might be fixing that anyway, but it doesn't matter, right? Like, I want to deal with. So this is a much more accurate, crazy situation now, right?
Yeah. Okay.
Length and bytes. Here's a complete stream. Randomly send some to this function. We now are going to have to be in this scenario. And I just want to know that we're there for this first run. So I'm going to say just 3, right? Just to see it. So perfect. I saw 3s in here. We should see that. All right, let me get rid of it. Program didn't run forever, so that was good. And I need some carriage return line feeds. So hold on. I think it worked. So
there, yeah.
Carriage return line feed. We'll do 2 there. Let's see. Why is that now?
Okay. Yeah.
Worked, bro. Worked. It worked. We can now process our protocol, which is length bytes, length bytes, length bytes, whatever that is. And we're processing it sort of perfectly now with this little algorithm, right?
Ooh, okay.
Now, there could be ways for us to be a little bit more efficient here. All right. And I could do something like this, though I don't think we're ready for it yet.
Oh.
Okay. And what this is showing me is that we're going to be, my guess is this is showing me allocations, right? So everything we're doing here is about allocations now, right? There's allocations going on there. Slice inbounds. Now this might be, no, we've guaranteed.
So what is that option that you hit doing that now they're all
It's
highlighted?
using some of the Go tooling. Instead of running it manually, it's running it inside your editor. And it's sort of trying to show you. So is slice inbounds, right? Now, what it's trying to say here is that the compiler felt like it has to do a bounds check here. Now, I would have thought, thanks to this if statement, because we said if the buffer is less than or equal to 1 break, it would know that it had to at least be 2 for this to work, right? So this one is interesting to me that it's coming up. this is telling me that these things are, this is all escaping to the heap because it doesn't know the size.
Yeah.
And we're doing conversions, right? There's a lot of inefficiencies there. But I knew that. Now, one thing that my brain thought we could do here alone, well, first of all, I don't know what the size of this buffer should be. So that's a problem, right?
Yeah.
Problem is that
The buffer can be.
I don't know what the size of the buffer could be. Now, potentially, though, we could pre-allocate some memory there if we were sort of being smarter about it. So let's just say for the situation that we're in right now, right? What if I said make bytes buffer 0
capacity
32K? Yeah. Okay. Now, we know that's going to optimize. Let me turn this off for a second. Source action, hide. Now I'm going to pre-allocate with no length, just a capacity, 32K of bytes, which I know right now is more than enough that I need. And that's still fairly small. So we're going to have one allocation now, okay, for this. We got to be smarter about our buffer. But we do know that at this point, we want to add these bytes to the length. Now, my brain says that we should be able to also use a copy.
Okay.
Where we say destination source, I think it is.
Source destination
source. However, I can't just say buffer because I want to copy it to the end of the buffer. So I should be able to say, well, whatever the length of the buffer is. Right?
Put buff to it. And why is copy better than append?
Because it's not going to be this function call over and over, like appending each individual value one at a time. This can be like a bulk copy, where I'm just going to say, take these bytes and bulk copy them into this buffer, starting at that length.
Okay.
They're going to be much more efficient. Again, we're dealing with small things, but when I do the Veradic signature, that's going to require a loop underneath the covers, pulling each value off as a parameter, right? There we're in a tight loop. This is just a memory copy. It's take these bytes and copy them to this memory location.
Got it.
But you need guaranteed bytes, or this is going to what? Blow up.
Blow up, yeah.
You need guaranteed bytes.
So you need to allocate the memory first, so that way you can copy onto it.
And 32K is fine. It's a small number. Now, ideally, if I can find a way to do this on the stack, which we can, then there won't be any allocations at all. But let's just not worry about that for a second. But here's the problem now. I can do that, okay? This is fine. This is fine. This is where things are going to start going bad, because what's going to happen is I'm going to start taking memory away out of that 32. And there's no way to get it back. Once I do this slice operation, I'm basically going to start taking bytes away from the backing array.
Oh, okay.
And I'm not going to be able to get back to them. So we can't necessarily, again, if I'm trying to be stupidly efficient here, the idea would then be that we have some buffer and we have some buffer index. Okay.
Okay.
Now, we could say that the buff index always points to, we can have two of them if we really wanted to be super efficient, right? Buff index, well, let's just keep it like this for a second. The buff index would point to where the next byte of data is that we have to, that we're managing.
Okay. So instead of slicing it out, now you just kind of maintain position.
Some position in there.
Okay.
Okay. Some position in there. So that would mean that the length would be in some buff index and buff index plus 2, because wherever we are in that buffer,
plus 2,
right? We want that index plus 2, not including 2, but it would be that. And now instead of doing this, I want to increment the buffer maybe by 2. However, that's fine, right? We're adding right. I'm adding bytes to the buffer at the beginning of it but this is like my read index. Let's call it a read index, just to keep it a little cleaner. This would be a read index.
Okay.
Now, think about this. We added some bytes to the buffer. We're at our current read index. We said, fine, we're going to read the next 2 bytes. Then I'm going to increment the read index by 2. I'm not getting rid of bytes right now.
Yeah.
But at some point, we've got to be able to see this is to do this. I think is going to be overly complicated. This is almost like a circular buffer where you're going to constantly be moving forward in the buffer, but at some point you got to come back around.
Oh.
You see what I'm saying? Which makes all this really complicated. Is there a way to do this where you never have to go beyond the length of the buffer, right? Now, we know something about Kevin. We know that this Kevin function always processes the buffer.
Okay.
We know that, right? At some point, the buffer always goes back to what?
0.
0.
Yeah.
Buffer always goes back to 0, doesn't it?
Yeah.
Okay. The buffer always goes back to 0. So let's roll this back for a second. I think I'm making this more complicated than I need. The buffer always goes back to 0. Always goes back to a length of 0. That's going to be super important for us to remember. So anytime that we're doing this copy, right? Ideally, we are going to be copying it into the beginning. Anytime we call Kevin, our buffer is kind of starting over. We should be...
Oh, because it's already 0. It should be 0.
However, there's no length, so that copy is going to blow up, actually.
Because there's no length.
There's no length. So if I go back to the original append, at least we'll have efficiency in knowing that the length will... The key is getting the length of this buffer to always go back down to 0 without losing capacity. That's going to be the entire game here, right? And the code we're going to write is always going to assume at this point we're never going to get more than sort of 32 bytes of data.
Okay.
Now, here's something else, though, that we can assume. We know we're going to process this entire byte slice. We know, however, that we're going to process the whole thing. And we know we might have some remainder that comes in, which is why we sort of do this, right?
Yeah.
Let's go back to this scenario here. We have more bytes than we expect. We have less bytes than we expect. But we still always end up in a scenario where the buffer is what?
0.
0. We always end up in a scenario where the buffer is 0 because we're always sort of writing bytes, right? We're always printing bytes. We're always streaming bytes. We're always processing the bytes.
So it will always be 0 because if not, you're missing data.
Because at some point we said length is true, and now we know that the next bytes that we're going to process are what?
The
However, we can return here
Prefix.
not having enough bytes to process anything. See what I'm saying?
We can't. I thought
We could.
the if.
The if says break out of this loop because we don't have enough bytes to get the length. And so we had that sort of carried over. So what I'm trying to say is there a way to simplify this even more? Is there a way to minimize all these little allocations? Is there a way to create a buffer that we could just sort of process? We know that we have to keep history of the bytes, right? So I'm going to do the following for a second. I'm going to put, this was originally what? This, right?
Yeah.
Okay. And we know that this worked. Okay. Let's write another version of Kevin for a second.
Okay.
Okay. I'm going to write a Kevin 2 because I'm thinking about one idea here.
Okay.
Every time we call Kevin 2, let's say we do that. Okay. We do that. Let's say that we can guarantee that the buffer always is going to have a length in the beginning, just for a heck of it for a second. So if length of buffer is less than or equal to 1, return, just for now. Now, let's say we did this next. Okay. Right? Then we could say if chunk length, okay, what we're expecting, is less than the length of the current buffer, and there's 2 bytes that we have to throw away. So if chunk length, so the chunk length could say I'm expecting 10 bytes.
Yep. I'm expecting 10 bytes.
So if 10 is less than the current number of bytes that are in there, minus 2, because you got to throw those 2 bytes away.
Okay.
Then we know we don't have everything yet, do we? So we could return.
Okay.
We can return. So do we have enough bytes for length? Okay. Do we have all the expected data? Oh, but this idea won't work because if I want to send a file, I'm going to say what? No, this is a bad idea. If I send a file, I could say there's a megabytes. I was going in a direction where why don't we store that length, right? And then process it. But that's going to be bad.
Oh.
Because then I'm going to need all that memory.
Yeah.
The point here was every one of these print statements was a write to disk. Every one of these print statements was a write to disk, right?
Yeah.
But even that, whoa, a second though. Even that doesn't work because again, go to a scenario where we're going to send 1,000,000 bytes. I got a 1 meg file. I'm going to send 1,000,000 bytes.
Yeah.
Right? Well, again, yeah, no, I'm not going to be sending, I'm not going to make the length 1,000,000. I'm going to send 496 at a time.
Yeah, you're still
There's going to be I'm still chunking it up, right? So let's just go back to this for a second. Assuming that the chunk size is reasonable, which it could be, then one idea here is that do we have the chunk size, right? Do I have, let's say, even if it's 32K, right? Do I have 32K? Every time that I'm going to call this buffer 2 for a second, right? And buffer 2 can start out, let's say we're going to, as a 32K, 1024 times 32 is the fastest way I can think of doing it all the time. So we're going to append, but if I'm doing append, I got to say 0. All right, so I'm going to append this into buffer 2. Okay.
Okay.
Do we have enough bytes? And then give me the length. And then do we have that many bytes currently in the buffer? The answer is no. Then I return. The answer is yes, and we could have more, right? We could have, we'll never have less. We could have equal and more.
More bytes, yeah.
Right? So let's say I stole this for a second. I don't know what I want from here. Then I'm going to take the current chunk length. Okay. But see, I don't need a global variable for this. I'm going to read the chunk length every time, let's just say. I'm just going to do this again. Let's just say for whatever reason. So I don't need written anymore because I haven't written anything yet. And I know the buffer has everything in it up to the chunk length, right? But now this is the key. The key is I want to take that chunk length. This is the key to everything. It's how do I efficiently take that chunk length out of the buffer where we don't lose, I don't have to create a new backing array, in other words. Because all this is going to do is create a new slice where we're pointing down into the slice. But at the same time, there's bytes there that I don't want to, let's just see if this works first. Okay, because look how much less code there is here.
Yeah, a lot less.
This is add to our buffer. Do we have enough bytes for length? Okay, whatever, process the length. Once we've got enough bytes there, print it. Now, there is a scenario where, well, we should always, if everything's working, we should always send it with all the right bytes, right?
Yeah.
So let's see what happens if we use Kevin 2 for a second.
Yep.
All right, so
slice out of bounds.
That's fine.
Out of range.
Like 68.
Capacity 0.
Because I'm using the wrong buffer.
Buffer 2.
My bad. So we got to I'm happy, she, X or S, and then we also panic on 69. Okay, fine. So I think it's because I'm not checking that we have enough. There's one more thing I'm missing here. Oh, no. If the number of bytes we're expecting is less than the number of bytes we have returned, this now is assuming that, but I can't be looking at 0 anymore, can I? Oh, I can because of this, right? It's bad right now. It's bad, but
because that's going from 0 to chunk length, and then this one's going, it's basically going back to 0. Or no, it's checking from beyond chunk length.
Yeah, so on the first time, this is fine because we have those bytes there. But we may have an overflow of bytes that we needed.
Yeah.
Which is why I'm trying to sort of keep everything after. But this is also inefficient because once I write these bytes out, I almost want to shift all the bytes back to the beginning of the buffer. It's like, it's almost like once I print the bytes out.
Yeah, which would be the right or whatever.
Right. I want to copy. Remember, what is it? It's destination source,
Destination source. I feel like it should be source destination, but that's just how my head thinks it.
I wonder if this is what I want to do. But I don't know what the length. Yeah, but the length is okay. Length creates problems here for me. What's happening is length is creating problems for me. So let's say that we stop using append for a second and we try this. I need to maintain my own sort of length here. So let's do that for a second. All right. I'm going to use my own length here for a second. 0. So instead of using append here, let's use copy again. So we're going to copy to buffer 2.
Okay.
Buffer 2. But where in buffer 2? Based on the current length.
Buff length.
What's coming in for buff. Okay. So wherever the length was, I'm going to copy those bytes into there. I've got 32. As long as this number isn't larger than 32,000, right now we're going to be fine. Now, this says I got enough bytes in here. Now, but after I do this, buff length now has to change to what?
It has to be...
We have to, the length of the buffer. Let's see. Right?
Length of buff. Oh, okay, because now that, that's
we just
gonna be
copied
buff.
them in.
Okay.
I don't think copy returns the number of elements copied, n, right?
Yeah.
So we could just be really smart about this and say n here.
Yeah. Okay.
Okay. So we just copied that many bytes in, we increment the length of that. Okay, we look at it, and we now know that the buff length minus 2, right, means that we've got the data.
Yep.
So we then go and we say, we want to print this data. So here I'm saying print everything from the beginning of the slice. But it can't be, the beginning of the slice has the length in it, doesn't it? So from 2, forget about the length.
Yeah.
To the chunk. Now this is the key to everything. Because what I want to do is reset the buffer, right? I want to reset it. But what do we have to reset it to? It's going to be 2 plus the chunk length. Let's just do the math, right? Because we've processed that data before already. So all of that data has to go. And that's fine, right? This is we've printed all this out.
Okay.
So I want that gone. We printed from 2 to...
So you're taking out the 2.
To the... Actually, it would be the chunk length plus 2. Okay. So from 2... Oh, no, to just...
But why would it be... Yeah.
Because it's index A through index B, not including B. And the length isn't an index. It's a number of bytes. So I got to add the 2 back to move the index over.
Oh, okay.
Okay, which is fine. And then what it is I want to go back and I want to replace all the bytes now, starting at the beginning of buffer 2. But what bytes do I want to copy from? I want to copy these. But how many do we copy? I can't just say, I don't want to say all of it, because that would be sort of inefficient. I have a buff length.
You go from there to the...
Right? I know what my current buff length is. I know that the chunk length is greater than the buff length, minus 2. Like, I can do this and it will work. Let's just see if this will work. I don't care if I'm copying zeros and stuff. But the key is the new buff length after you do this. What is it? I guess, right? What is it? It's not... See, that's the problem. It's not everything.
No.
So we got to fix this problem, because let's say the buffer looked like this.
Okay.
Okay. And that would mean that the buff length is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say we were going to copy 5 bytes, right? And we have really, we have that. So 11, 12, 13.
Okay.
That's what we would have here. Okay. 13. The dash is being our integer.
Yeah, they're
So
the prefix.
what did we do above there? We said print. Right above, we said print from index 2 through 13. Ooh.
Through
We really want to print from what? Index 2
to the end.
Okay, which is what? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 has to be 13. So, and we said this was the chunk length, right?
Yeah, it's chunk length.
So we want to say print from 2
to
index 13, not including 13. Again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the chunk length is actually what we want there.
Yeah.
Okay. That should print that. Now,
non-inclusive.
let's say that this is what we had in the buffer for a minute, though. Okay. Just for a long second. This is what we got in the buffer. In this particular case, how many characters we got there? 72. Okay. So our
72 or 23.
The chunk length is going to be 13, but what is our buff length? Our buff length is going to be
23.
Oh, sorry, 23. Okay. Buff length is 23. Let's assume that the chunk length here is 13 still. So we come in here and we do this. Okay. So we printed this out. Now, ideally, what I'm trying to do is change the buffer to look like this.
Yeah, because it already got.
Right. Which would then give us a buff length of 10.
But then that's.
So this is where I'm going. This is the code that we're trying to do.
Yeah.
We're trying to take this and have it look like this and set the buff length to 10.
Yeah. Basically restarting the same sort of process.
So we know what the chunk length was. It was what? 13.
13.
Which makes it really 14, 15, doesn't it?
Yeah, because we're subtracting the two.
So if I go and I say, let's copy chunk length plus 2, which puts me
so you're skipping 2.
But my chunk length was 13, 14, 15. That puts me here, right? Try it again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's byte position 13. See, the chunk length is wrong here. What is the chunk length? 1, 2, 7, 8, 9, 10, 11. The chunk length should have been 11 here.
It's 11. Okay.
So now what we do is we say we're going to print from 2 through 11, right? 2 through 11.
Not including 11.
Right. So
it's chunk length plus 1.
So this might have to be chunk length plus 1, right? Now I come here and I want that through chunk length plus 1.
Chunk length plus 1, which is going to include the K.
Right. So now we'll clean this math up.
Yeah.
This is where I want to start copying bytes from.
So then you don't need the 2 there. It's just chunk length plus 1.
Chunk length is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, right? 12, 13. I'm going to need that. This extra 1 might be, I need to be here, essentially.
Oh, okay. So you need the 2 there.
Right.
Not updating the value.
But my problem right now is, oh yeah, and that's fine. And then I just need to do that up to the buff length.
Up to the buff length.
And then n, that should give me the number of bytes that we copied. That should work. And now what we're doing is we're living within the scope of this.
Yeah, okay. So this 2's here, but this 2's here because this one's there, and you always have to be offsetted by 2.
Yeah, we need a constant in here, right?
Yeah.
It basically is the it's the length, it's the 2 bytes that we're using
Prefix
for the index, right? Okay, yeah. Prefix. I'll do it right here. Prefix length bytes is 2, right? But that's too long. So let's just call it prefix for a second. So prefix,
Yeah.
prefix,
Oh.
prefix, right? The +1 sort of sucks, but I'm not sure that's right, but we can play it out again. Yeah. Let's play it out again, okay?
2.
So we copied a bunch of bytes, we incremented the length. We did that. We come in here and we pull out the length. We now know that, let's just, for our sake right now, this is what's in the buffer. Okay. So that gave us a buffer length of 23 bytes. We're going to assume that this represented the number 11 because that's what that is. So then we said, fine, print the prefix starting at 2 through the chunk length 11, but then you would say not including 11, so we added 1. We get this. Now, the idea is to take what's remaining in the buffer, copy it, and this is cheap. The copy's cheaper than the allocation.
Than the append.
Yeah. Move it over, and we're constantly processing in the beginning, right? So I don't know if this is going to work or blow up again. It blew up again, right? When
14,
we got to
14, 13, so it's off. It's off by 1.
Yeah, so it was 14, 13. So maybe we don't need
Maybe we don't need that. Yeah.
I'm happy. Let's not put that in there for a second. Okay, now we didn't get anything. And now we've got 82 again.
13.3 now.
Okay, so we definitely got something wrong here. But the other thing is we started printing. Oh, we didn't print anything.
It just said I.
I just got to
I.
And I also don't know how we're streaming it in just yet, but that's fine. So we may need to put a little bit more, like, do the following here. On the first run, print string of. Now, this is a full, this buffer is completely full here, right? So I'm going to have to do like buffer2 sub buff, but I don't know, like now we've got it down to a point where we don't know. So let's do this instead. If we get this far, we're printing, we should print the length. Just for now, length, and that's the chunk length, right?
Okay. Oh.
All right. So we know we have some sort of chunk length, but the other thing is, what is the size of our buffer length, right? That I don't know what our buffer length is. All right. And then the idea is that we're trying to display not the buff length, but the chunk length, right? Chunk
From
length.
Prefix to, we're trying to display that actual.
Yeah. So from 2 to whatever the chunk length is and what's in the buffer. So we got a chunk length of 11. We were supposed to handle 11 bytes.
Buffer length is
We
not.
only had 9. That's fine, right?
Yeah.
Because we didn't get enough bytes. So let's play that out. We had a chunk length of 11. It's only 9, and we're trying to print it. We didn't have enough. So we're missing an if statement here. Right?
To handle that case.
Yeah.
We don't have
We
enough.
don't know. So we need to know if the buff length is less than the chunk length, but it's more than that. Return, right?
Mm-hmm.
But we did this here, didn't we? If the chunk length
is less than the buff length minus the prefix.
Right, so how did we get here?
But why would...
The chunk length is 11. Oh, if the chunk length is greater than...
If the... That's what it is.
That's what it is, bro.
But the buff length minus the prefix, why?
Because that's the number of bytes.
Yeah. Okay.
So the chunk length was more than what we had in the
prefix. Okay.
That's me being dyslexic. Boom. Now, we're not there 100%. We're missing spaces. So we're missing a byte.
Yeah, we don't have the spaces. So,
And
yeah.
I'm wondering if that wasn't necessarily no.
There it is.
No, we're missing. Actually, it's worse, isn't it? Because even on the first one, let's put this back for a second. Okay, we're missing a byte, right? I'm missing a byte.
So maybe it does need to be 2?
Plus the prefix. But that would... Now it's perfect. Okay.
Yeah, I guess that makes sense.
Yeah. Now we're perfect, right?
Yeah.
And what's nice about this code is it's a lot less. This is us writing to disk, right? And I bet you,
smaller.
Right? It's a lot smaller than all this crazy logic. And I put money on it that I don't need. What am I doing, bro? I don't need any of this, right?
Yeah, a lot more simple.
I just need it. I've got a buffer, and I put money on it that if we now look at compiler optimizations, let's see. So this is just saying that there's a bounds check here.
Mm-hmm.
That's a CPU optimization. So since Go doesn't want you to be manipulating memory that you don't have access to, it's going to add extra assembly code there to validate that there's enough data in that memory space to do the copy. Now, if you were doing cryptography algorithms when you're in tight loops, you want to get rid of that assembly.
Okay.
The only way to get rid of the assembly would be to make sure that the compiler knew that there was always going to be enough sort of space for this copy, right?
Okay.
How can you give it information to make sure that it knows that, and right now we can't unless we used an array of some sort, right? I said 4096. And then I went.
But we're missing the 6.
Oh, but even that maybe is enough because.
But that's our like size of chunks anyways, right?
But you see how all the blue lines went away.
Yeah.
Now,
because it knows.
why did the blue lines went away? Because now it knows that the data coming in here will never be larger than what we've allocated here. We just got rid of some extra assembly language code.
So why does that need to be 1024 times 32?
Because I just wanted it to be 32K. It could be anything we want.
But it could be like, what if it was that exact same 4096? Would it still
all
work?
This has to be smaller than this.
It just has to be smaller.
Yeah, because that's the destination and that's the source. And so at compile time, if it knows the size of things, it can do these optimizations. So here's an optimization where we got rid of the bounds check. Now, that means that the caller then has to just pass in an array of that.
Okay.
And we're not going to necessarily do that, right? So in this particular case, if we needed the CPU optimization to get rid of the bounds check, now you know what you'd have to do, right?
Got it. And
Now,
there's cases where you'd actually need to do that kind of an optimization,
yeah,
like
if you're
that
doing
small.
cryptography where you're in these tight loops because you're trying to hash something where every nanosecond matters, hell yeah, you're going to do shit like that. You're going to write the code and rearrange the code in a way where the compiler during static code analysis can get hints that it doesn't need to do this and do that. Now, what's also interesting here is, and it doesn't, I mean, to me, it makes sense. It's putting this on the heap too, this 32K buffer. But this is, I would call this a productive allocation. It's a single allocation. We're not doing all the little allocations that we remember the optimization here.
Appends and
and for what we're doing, this is not going to be a big deal. Now, we're doing a print here, right? And so this is a conversion from some bytes to some other bytes. The conversion would happen underneath anyway, but we could probably, again, we're going to write it to disk, so I don't care about this one. And it's all buffer too because, again, another
it doesn't
slice
know.
inbound.
It
It
doesn't
know. But we're going to live, like, we can live with that. What's nice about this code change is we can much easier maintain this, right? So this to be would be our write bytes to disk, right? And then this is a move bytes to front of buffer. Pretty cool.
Yeah, no, that was
a lot
interesting.
less code and much more efficient.
It was interesting to do that kind of like optimization focused refactor.
And so we're basically allocating memory and managing it ourselves.
Yeah.
Right? We're managing it ourselves. So we get a single allocation now. And this code here is just, store new bytes into the buffer. And now we just store those bytes into the buffer. Do we have enough bytes for length? Do we have all the expected bytes? And who cares? We're maintaining a small buffer. As long as the other side is sending smaller chunks, which we can do, then we're fine.
So the only thing here is just the assumption that it's under 32.
In this case, I've hard coded the buffer, but we can do that too, right? We can make some assumptions since we own all the code.
Yeah.
But I like this code much better.
I agree.
And yet we're reevaluating. You could become a little more efficient. Like these are maybe you don't, whatever. Like at some point, there's a diminishing return on the optimization for complexity.
Yeah.
I didn't like any of this. This was bothering the heck out of me. This was impossible. This is easy to sort of think about and reason.
Yeah, definitely.
So now we have our algorithm, don't we? So let's go back a second now to where we were when we were hacking on this. At this point now, all we need is the buffer, right? And let's do this too, just to edit, rename buffer. So in this case, this is the buffer, right? And we can say buffer is that. We also need a buff length. Actually, I don't need this anymore. I got a buffer. I need a buff length, which is an int, and I don't need any of that. How cool is this?
Much more simple. Yeah.
Now, we still decided to do our sort of metadata. Okay, I don't remember. Oh, file name and size, fine.
Okay, yeah.
Again, we'd have I'm doing this on one instance. We'll have to figure that out. But this read is cool because now all that this read does is it takes whatever bytes are coming in and does this, right? This was h dot buffer, right? The length. This is the data. H dot that.
And
Yeah.
and it,
But n is the number of bytes also read, right? So we can sort of do this. That's the number of bytes copied, right? And that's kind of cool. So now we're just going to, right now, notice that we've pre-allocated
4096.
4096 at a time, but the buffer could be of some bigger size, but the compiler will now get rid of, it could get rid of the bounds check on this. If it, well, maybe not, because it doesn't know if where the buff length is. It will still have to do a check there.
Yeah.
But whatever, that's not going to be the reason why we're not as fast. All those little allocations were going to kill us. This now is all a single allocation here, really. And actually this could be smarter too, because we're only doing this one time, right? So instead of this, but the compiler knows the size of this can be on the stack. So that's not going to be a heap allocation.
Okay.
Compiler knows the size of it. It's super small. So that will be on the stack. We don't have to make it global.
Yeah.
And then this is already going to be an allocation, but we don't care. That's one allocation, a small one. So that's good. And now we come back here and we now have sort of the rest of this code here, right? I'll bring that in. Hold on. And the cool part is we didn't even put this in a loop, did we? Ooh. We got this to work even though we didn't put it in a loop because once the final data was written, because we're always processing one chunk of data at a time. If we don't have enough of that chunk, we return expecting it to come back. But Mike, we got everything. I think we stumbled into that by accident.
Yeah, because there was the loop.
We may have stumbled into.
But how is it
not needing a loop?
How is it still getting everything?
Because what's happening is when the last chunk comes in, it's completing the last chunk, and we've already processed the other one. We're getting, I think we're getting lucky.
Huh.
We're gonna see what happens though.
Not having the loop saves some time as well.
No, it's kind of where we're also getting some of the simplicity from, right? So now when we do process, we write that chunk to disk and we move the bytes and we get, that's super interesting, huh?
Okay.
And just for our purpose here, just to,
yeah.
So that's super interesting, bro. I just realized we didn't have that in a loop, did we? And this really needs to be a new. So now you've got the server side code.
Okay.
We've got a handshake on the bind. We're going to read 4,000 bytes at a time. Oh, I think we need n here. Yep. So we are going to need a value here
V,
because you can only copy up to a v.
Oh, okay.
Right? You said here's a buffer, here's a 4,000 byte buffer, fill it. It may not fill it on the last read.
Yeah, so you just need to go to wherever.
Now, the other problem is that I don't know if this returns a EOF with bytes or not. Which is like some of these APIs at this level, it could be a failure, but it could be a we're gonna see this, right? It could be that the very last read sends an IO EOF
Okay.
with a number of bytes, and we still have to process that last one. So we're gonna look for that. We might see reading line error and it says EOF, right? And so watch, like I'll do it this way for a second. Print a reading line. So there may be some bytes there. In other words, there might not be zero. I don't like these sort of APIs, but they happen in Go when it comes to some of this stuff. So we'll see what happens. Okay. Now, that's the server side of everything.
Yeah, now there's a client side.
And the client side, now, the idea is to change this a little bit. I don't need two Go routines. I don't need any Go routines, honestly. What we want to do in this particular case is wait for the server to start. I want to dial context key. It's fine. The key should be a string, the type address, and that returner or whatever. Now, this is where we wanted to send, we want to do a protocol, right? However, we have these handlers that we still have to implement here. So this is where we're going to send the data, all right?
Okay.
What we have to do, though, is the bind. There isn't going to be any reading. There isn't going to be any processing. We're not.
Oh,
sorry.
but that's the
the server.
there.
I don't need any of this, right? Because we're not going to send anything back or anything. Return nil, 0, nil. I don't have my other thing on.
Yeah, this is where the.
That's fine. But none of this is going to happen. So, fine. This is where we've got to implement the other side of this, remember? So we're going to send to low, and we've got to send the metadata. in JSON. So what we've got to do is on the bind, we're going to do a client.read, con read, and we're looking for how many bytes, basically. 1, 2, 3, 4, 5. That could be like 6, but but we're sending a carriage return line feed, right? So we might be able to use our buff IO, right? I think, dude, why do we got so many changes?
It was after you did that vendor.
Oh, we got rid of something? Okay, that's fine. I'm curious if I took code away where we were doing this is what I'm looking for. Yeah, that's what I'm looking for. So we could do this essentially. Oh, but I took the wrong code. Let's go
That
back.
was the read code.
I need the bind side first. This is sort of what I need. Yeah. Because then on the client side, we're going to do all that in the bind. Yeah, buff IO new reader. So let me come back here. Try this again. A new reader. I want to read the line, right? I'm expecting it to be hello. I'm just going to print it. I don't particularly care about it. Whatever. And then we're supposed to do a metadata thing, right?
Yeah, metadata.
And the metadata has a file name. File name will just be build.txt. And it's going to have a size, which really doesn't matter. So we'll just call it 10K for now. All right. Because at the end of the day, we're just going to get these chunks, and then it should go EOF, and then we should be done. And we can compare the size, and then we'll do a hash or something, right? We're not going to finish that today.
Yeah.
And Harrison said hi. I just saw that. And now we're going to do a JSON.Marshall MD, and we're going to get some data back from that, and or an error. And if, again, I don't have any of that turned on, we just do this again. Marshall. And now the most important thing is we do a client.con.write, and we send the data. And that means that this gets this data, and then it's waiting for us to come into our little main program here and start sending some bytes. So what we could do is steal all this, bro.
Okay.
Right?
Yeah.
So let's steal all this code. And in here, instead of calling Kevin, right, we're going to use our client connection, CLT, do a send. I don't know if I have a right. I have the con dot send con dot write. Sorry.
Right. Okay.
And I'm going to write those bytes.
Okay.
Right? Then it's going to drop the connection, which I could do myself here.
Connection.close.
Close. And see what happens on the other end.
Okay.
Okay. And then we could just say func.println client sending bytes. I don't know. I have no expectation this is going to work, but it would be kind of fun, at least here in the last 15 minutes, just to see. So the idea now is we're going to start the server. It's going to start listening. We're going to start the client. Then we hit Control C to shut the whole thing down.
Yeah.
The client is going to connect to the server. It's going to wait. No, before we try to connect, we're just going to wait 300 milliseconds so the other side comes up.
Yeah. Okay.
Then we're going to say client send, and it's not going to be a hello, but
it's going to be all
client
that.
Send. Or we already have client sending bytes, right? We're going to send these bytes. And one of the other things we should do is print out the metadata here. Print server metadata MD. I don't know. Whatever, right?
Yeah.
Just we can clean all that up in a second. But and then we should see bytes to disk, and it should be everything.
Okay.
Yeah, I don't really want to run this. Okay, this is going to blow up miserably, okay? But let's see what happens. Oh man, it's blew up miserably.
Waiting,
let's see. Client bind.
We got the client
I'm
sending
happy.
bytes.
Oh?
We got the client sending bytes, and then
I think it worked at some level. Because I only print out the bytes. Let's clean up the logging. But the only way I would have seen this is the only place we print this. Oh, no, we printed here too. Okay. So it didn't work. I'm printing it here too. And then we said client sending bytes, right? So that's why we saw it. All right, so for sure it didn't work.
And then client sending bytes.
We have this weird thing here.
Started and then shut down immediately.
So we'll fix that. And I have this weird thing here too, which is the data. So I got to put that in string maybe. Okay, so what do we got here? Bind on the client side, bind on the server side, bind on the client side. Let's look at bind on the client side. And this should have been string. All right. That should have been the word hello. Okay. And I didn't see on the server side bind. I should do this. All right, let's just look at these first log lines for a second. So there's the hello, right? Oh, on marshalling metadata.
Yeah.
Okay. So what's happening is this is failing here.
The unmarshalling
the meta. And my guess is that when we write this, when we send, okay. So I know what's happening, right? When we unmarshal the metadata, we're getting something really interesting here. So let's do this first. Let's just see what we're sending. Because we should be sending something there. Doing something wrong on the send, obviously, right? So we did send this. And then what we get on marshaling metadata. So let's go back. So we know we sent this, right? Which is right. But when we come back here, let's print out what's in the line. Let's see what we got on the other side.
Unmarshalling metadata invalid character.
I feel like we got this.
Okay.
I don't know if this is what's failing here. So let's just say server on marshaling, because I don't think we're getting, but some text started coming in it.
Server
and that's fair. Let's do this too. My logging is so bad right now. One, two. See? Something here on marshaling metadata invalid character /v.
From server. Yeah.
But I don't have a /v here. So I have to look at the bytes maybe.
Happy.
And then it started sending some stuff, which it's pretty close. I mean, it's really, really close, right?
Yeah.
We just got to fix this sort of metadata thing. And, oh, I know what we need to do. That's my fault. I can't send this unless we also write the carriage return line feed. Remember? Because we're expecting a delimiter.
Oh.
I did it that way, right? Just to keep it simple. So those are the bytes. I'm not sending the carriage return line feed. And this is doing a, I believe that's what's going to be the problem. I'm saying read line, and probably what happened is it handled it on a close or something. There it is. So we don't have that other error anymore,
No.
right? We did get the metadata, but
Server waiting on read. Oh, EOF. Reading line.
Yeah, well, reading line is going to be hopefully not here. Yeah, we did this. We did this in a couple places, right?
Yeah.
Reading line.
Bytes. Yeah,
zero.
that one.
But EOF, remember I told you that
EOF.
could happen. But it was 0 bytes, which at the end of the day was fine. So what I'm wondering is why we didn't.
Waiting.
All this feels right, except for not seeing us return. So is it possible? So do I see server waiting on read here?
Yeah.
But right out of the box, we got a
EOF,
right? Suddenly we got an EOF. So let's just double check a couple things, because once we fixed sending a carriage return line feed for the bind, then we return from this bind. Everything else now is this code up here in main saying let's sending client bytes, right? Do you see sending client bytes? I don't.
I do not.
Okay. So I don't see this now.
Oh, there it is. Client.
Client manager started shutdown though.
Like immediately.
Why?
You have that connection close underneath it, but
let me think. We created a TCP client. Oh, well, what does this TCP function do anyway? Oh, it stays in the Go routine. It stays in a Go routine. It's supposed to just start its thing.
oh, and
Let's not close this right away. It could just be me being stupid for a second. So the idea is that this is in a Go routine, and it just sends these things. Let's not close it for a second. And then I still don't know why I see this. This I don't understand. Oh, I guess this is getting called because like I'm not holding the server long enough or something. But that should never happen because we're not doing a shutdown here. It's almost like, why is that shutting down? That is the question. We send the bytes. Start client sending bytes. All right. This is us sending bytes. Maybe this is failing and I'm not checking it, right?
it's always the error you don't check.
Always something is shutting down too soon. That is the problem. And so we got to find that. Something is shutting down too soon. That's the problem. So let's figure that out because this time.
See, but it's saying client G. Oh no. Client.
Yeah, something is shutting down too soon on this little test program. So server stays here. I don't even need a Go routine for this, man. Like I just don't. Just run this code. And then nobody shuts down until I hit Control C. Now the TCP client, right? It creates a new manager. Oh. There it is, bro. I had it in a loop before. So that's what's causing it to all go to hell in a handbasket. Right there. So let's just do this for now. We'll clean it up, but this is really
so
client message. I'm happy. She's.
And then it says write bytes to disk. I'm happy.
It got a bunch of. It almost feels like it got everything. We have to do some more debugging here. Server client message. Hold on. So we know that we are just sending that stream over, right? We're sending the stream the way I want it to. Okay. So sending client bytes. It's funny that happens before all the bind. Then on the server side, waiting on read, client message. But there's a bunch of
Like, yeah.
Weird shit there, but maybe because of what we did. So let's not put that in there because that's not helpful. What would have been important here is writing bytes to disk.
I'm happy. That's it. Only the first. Until the
And this is
space.
why we need the loop, because I think what happened is the other side sent all of this. You're seeing a bit of the length here.
Mm-hmm.
So we're getting, that's because of a length issue. We're getting a lot in one shot, right? So
Yeah.
even though on the right side, we're doing right, a bunch of rights.
Mm-hmm.
The other side is assembling it because it said waiting on read, right? And I bet you if we put that's how many bytes we read, right? All right, so we know what to do. Where is here? Look,
230.
right? And
We got school starts.
so what's interesting here is we didn't handle this scenario, which we will next week. We're getting 230 bytes, and we need to be in a loop here. All right.
We need to be in a loop
Yeah,
so
we
we
need to be
can
in a loop.
process.
So
That's what it was. It only did it that one.
yeah, we
time.
need a loop here for getting a bunch. We're very close. So I'm going to put this note in here.
This refactor was cool though.
Yeah, we're really close, bro. This is going to be no big deal. I guess when we did the make tidy, it got rid of some stuff I didn't realize we still needed.
I don't remember the last time make tidy was on this project.
All right. So close to network, basically data control, right?
Mm-hmm.
Get push. Super close though, dude. Super close to having this sort of working. But you're starting to see how nice the standard library is. If you can create delimiters and
Yeah.
you do things, you don't have to worry about. This is why everybody's doing delimiters, carriage return, line feed, JSON documents that end in a carriage return, and we're just letting the standard library pull these.
Yeah, do all of this for us basically.
But now that we're doing it ourselves,
you see it
real simple length data, just go. You have no idea what the network's going to do.
No.
So if we keep that logging, it's not going to necessarily be 230 every time. There's a lot of chaos that goes on at the network. Basically it's level 5. It's the socket level.
It's kind of crazy how they wrote the standard library to kind of handle all this.
Oh, as a networking gurus, but that's why Go is so powerful, because you can do these things without the complexity, right? Like
Yeah.
they've done it. Anyway, totally out of time. We'll save this. Sorry. We'll be back on
Thursday. I won't be here Tuesday. Thursday.
I can't do the show without you, son.
Oh, you can do it that way.
No, I don't want to do it without you. All right. And then we'll have the lovable guy. So, all right, we'll figure out the schedule. All right. Maybe I can get somebody to go on with me on Tuesday and hack on something else. I'll wait for you on this.
Okay.
Do the show on Tuesday. I won't work on this. And I'll get Florin or something to hack with me.
Yeah, sounds good.
All right. Bye, everybody. Bye.
Bye.